Okay, for this next example, we're going to have to talk about something very specific that happens with our interval of time. That's going to be the tricky part here. So the bacteria Streptococcus lactis doubles every 26 minutes in milk. If a container of milk contains 4 bacteria, write an equation that models this scenario and then graph the equation. So the keywords doubles, and then you have the time frame for which it doubles, and you know what you're starting with. So that should tell me that we want to do y equals a times b to the x. But we have a little bit of a trick with the exponent up here. So we're going to start with a, which is your initial amount, which is 4. And then b, which is the rate at which it's increasing, which in this case is 2. And then x is a little bit tricky because it doubles every 26 minutes. So that's an interval of time. Now, x is going to be the number of minutes, or I should say the number of intervals. So the number of intervals. So the trick with that is if we're measuring in minutes, then it's actually going to be x over t, where t is 26. T is the number of minutes it takes for an interval to happen. And this is the number of minutes that have passed. So for example, for one interval to pass, x would have to be 26. So 26 over 26 would be one interval. In other words, it'll double one time. 52 minutes pass, that would be, that's a 2. That would be 2 intervals. Okay, so in other words, however long it takes for the interval to happen, we put on bottom, and then the actual units that you're using to measure go on top. All right, so we're actually going to change this to x over t for our exponent, and so our equation actually turns into this. Y equals 4 times 2 raised to the x over 26. Okay, now we do that specifically because we're graphing. In the previous lessons, in Module 2, we didn't do this. We just understood that if something's happening every 26 minutes and it happens for a period of 52 minutes, then we need to just convert our exponent up here to a 2. You know, basically we did our math without actually changing the formula. But because we're trying to graph this and we're going to plug it in a calculator, we need to be able to write it as a part of our formula. So that's where this gets a little tricky. All right, so now what I'm going to do is I'm going to make my table of values, right, my XY chart that I can then use to graph. Now I'm going to be very picky about what X values I use because I want them to give me nice, neat whole numbers up here. So the first one I'm going to use is 0. The next one I'm going to use is 26. And then I know the factor, I know the multiples of 26, so 52, and then after 52 would be 78, and then we can go on from there. But we're going to plug this in the calculator. We're going to look at these values, and we may actually add a few to it as well. So in your calculator, again, clear out whatever you got previously. Get back to your main screen, hit table. If you've typed something in, like we did in the last example, you see it's still there. Hit clear, it'll go away. So we want 4 times 2. All right, and then the trick here is going to be to use the n over d key in the exponent. Right, so now I have an exponent up here, and so it's x over 26. All right, so I hit enter, and I want to start at 0. And my step is going to be kind of interesting here. So I told you I was specifically looking for multiples of 26. So you can do 1 if you want to, and it'll give you x is 1, x is 2, x is 3, and you're going to get a bunch of decimals, and it's going to be kind of hard to see what's going on. Or you can do what I did here and go ahead and set your intervals to what you need them to be, which is 26. And now it'll only give me every 26th number, right? So 0, 4. And what that does is it gives you some nice, neat numbers in your chart. Okay, 52, 16, and the next one down after that would be 78, 32. Okay, I'm actually going to go ahead and write down a couple more. We'll write down 104, and I'm going to have to adjust my camera here a sec. So 104 goes with 128. I'm sorry, 64. And then 130 goes to 128. You'll see that last one wouldn't fit on my graph, so I'm going to leave it off. All right. Just to give you an idea of what I meant, in case you weren't understanding what I was saying, if I delete this out, if I do my step of 1, okay, I'm going to start back at 0. You start seeing all these decimal points, right? So what I want you to understand is it's not a different answer. It's just looking at all the points in between 0 and 26, which have decimal. They don't work out into nice, neat whole numbers. But we get to 26, and there's 26.8. If I were to keep going on to 52, you get all these decimals in between, and then by the time you actually get down to 52, you'll get your next nice, neat whole number, okay? 16. So I set it up that way on the calculator specifically so that I wouldn't have to sludge through all of those different numbers, okay? All right, so now that I've got my table, I want to go and I want to graph it, okay? So I've already created my chart here, and I'm going to bring my table back over. So it was 0, 4, X and Y. It was 0, 4, and then 26, 8, and then 52, 16, and then 78, 32. We'll plot those and we'll see if we get an idea what's going on before we move on. All right, so again, on this side, this is what we're talking about in the problem again? Bacteria. So this is the number of bacteria after a certain number of minutes. And again, I'm sorry for having to use the camera instead of the board, but to be able to show you the calculator stuff, this works a little bit better. So 0, 4, so not quite at 5. And then 26, we're at 8. Since I'm counting by 5, that's a little hard, but get it as close as you can. And then the next one is 52. At 52, we're up at 16. And then at 78, we're at 32. And I think I'm going to go one more. And if I remember correctly, it was 104 and 64. So 104 is my next line, and 64 is all the way up here. And what that should allow you to see is that we're starting to develop a nice exponential curve. Okay, and the next one will be 128, which would just continue that same pattern. Okay, so again, our equation that went with this was y equals 4 times 2 to the x over 26. All right, moving on to example 3. We're talking about compound interest.